Today we are going to talk about simplifying expressions by combining like terms. So our goal today is to get our expressions down to as few terms as possible. To start, let's go through a couple of vocabulary words. Terms we know are the parts of your algebraic expression. So 3x is one term and 5 is a separate term. Like terms are terms that have the same variable raised to the same exponent. So here, each term has the variable of y raised to just that one, which we don't see. So if we had that 3 as 3y squared, then these would not be like terms. But because they're both y and they don't have that exponent up there, those are considered like terms. We can combine them to make them 5y. Simplest form is when we have our algebraic expressions down to as few terms as possible. So let's take a look here. There is a big difference between adding and subtracting when it gets to our expressions. Here we have y plus y plus y plus y. Now we already know that when we add that, repeatedly add the same thing, that can be turned into multiplication. So we're taking that y and adding it together 4 times, which would tell us we can multiply 4 times y. So remember, this is repeated addition. 4y would be the same as y plus y plus y plus y. Here we have multiplication though. And remember, when we repeatedly multiply, that translates into an exponent. So we're multiplying that y by itself 4 times. Now, this is quite a difference here. Multiplying something by 4 or multiplying itself 4 times makes a big difference. So we've got to pay attention to that symbol. And then lastly, we have y times y plus y plus y. So then we can combine that by saying, okay, well, we've got y being multiplied by itself 2 times, and then we add that to 2 times y. Again, paying very close attention to those symbols. All right, so let's go ahead and take a look at a couple more examples. When we combine like terms, the first thing that we want to do is determine which terms are alike. And we can note those in a couple of different ways to help us see more clearly as we go through. After that, after we've determined what those like terms are, we can add and subtract our coefficients of these like terms. From there, we will write our new expression in simplest form. So if I look here at number 1, we've got 3x plus 9 plus 2x minus 5. So these two terms have x as their variable. But then here we've got 2 constants. So we can take those 2 constants and we've got 9 minus 5. That gets me 4. And then we've got 3x and 2x. Combining that will be 5x. So our new expression simplified down would be 5x plus 4. We've accounted for all terms, but we've combined them so that they are a little bit, it's a little bit easier to use. All right, let's go ahead and look at number 2. We've got 8 plus 3z minus z. So again, I determine which terms are alike. 3z and z are alike, and then 8 is a constant all on its own. So that 8 doesn't change. But we do have that 3z minus z. So remember that z, that second z has a coefficient of 1. 3z minus 1z is going to get me 2z. So this expression written in simplest form would be 8 plus 2z. We've got one more example here. It says 3b plus 5 minus b plus 2 plus b squared. So I'm going to go ahead and I notice that this term has a b, this term has a b, this term has a b, but it is raised to the second power. So that is not the same as these other two b's. This b is all on its own, b squared. They are attached, they go together. And then we've got our constants. So we've got 5 plus 2 gets me 7. And then we have 3b minus b. So 3b minus 1b will get me 2b. And then that b squared is all on its own. So my new expression, my simplified expression, would be 2b plus 7 plus b squared. Because this is addition, it does not matter. We can move around that order. If we write it out a little bit differently, that is okay.